This is the high concentration cell for determining zeta potential on the NanoPlus HD, NanoPlus, and even the Delta Nano. High concentration being that the sample suspension is opaque, and in cases where you don't want to make a dilution, because if you do make a dilution, you end up changing the zeta potential anyway, because you're changing the concentration of the additives, surfactants, particles, just about the whole system. Since zeta potential is a quality of the entire system, not just of the particles themselves, it's important not to do dilutions as often as you'd think. So the way the cell works is that you have a transparent electrode. It's a patented technology that only the NanoPlus has. The electrode itself is a piece of glass with a platinum coating. The light will pass through the the glass piece from this side and scatter from this side. I'll show you once I reassemble the cell, just to make sure that surface is clean. There's a little bracket here. This other side of the cell is the disposable plastic piece. I'm going to keep this O-ring because this O-ring is not disposable. Unscrew this part. This part is disposable, these two O-rings. This part is disposable. And then this O-ring on the other electrode is also disposable. Just take that out. So this is the other electrode, and here we'll replace this O-ring with a new one. I have a new cap. You have the big O-ring that goes on the inside, and the smaller one that goes on the inside also. And this is the new plastic piece. And I'll actually put this O-ring back on here. This O-ring is used to complete the seal around the electrode, so you don't want to forget it, or else you'll have the plastic pressing up against the glass and it may leak. So put that there. This slides into place here. And for this part, once you check this electrode, make sure there's like a little groove where it's supposed to sit. Once you have it in place, you just slide this bracket back over it, and then you just kind of line it up. There's like a little track here where it slides back and forth. Just make sure it lines up and presses up against the cell, and use the clamp here to hold it together. You have a little metal plate here connected to this screw, where you'll make sure it makes the connection, and you'll check the grooves here where there's hooks, make sure that they line up well, and tighten it up. You don't want to tighten it too much, you just want to make it finger tight. So this is the top of the cell, and now we're going to introduce the sample. We have some milk, which is obviously high concentration. It's opaque, you can't see through it. And we're going to fill it in the little hole. You can see the electrode right there. We'll fill it right inside up to that second level, just like that. And then from here, we'll take the metal electrode and submerge it and kind of move it around back and forth, because you want the entire distance between this electrode and the transparent electrode to be all submerged under liquid. If there's any air bubbles, it'll interfere with this the measurement. And then once you do that, it should, stand up straight like that. And we'll just take this cover and line it up and put it over. And all the O-rings should form seals. And once you tighten it, you should be able to lean it sideways. And any excess liquid will be in this chamber, and remaining suspension with hopefully no air bubbles between the transparent electrode and the metal electrode. You have the light path from here. Again, it scatters from here. It's a 30-degree angle, and it barely penetrates the sample in order to avoid multiple scattering, and it applies the electric field and looks for the electrophotic mobility by looking for the Doppler shift in the scattered light. And that's it for the high concentration cell. That's how you take it apart, place the plastic pieces, and fill it with the sample. Once this analysis is complete, we'll do the same thing again.